This is on valence electrons. I have a periodic table here with the transition metals taken out. The reason I took the transition metals out is because the valence electron structure for those is not as regular as what we see in groups 1 through 8. Group 1 has 1 valence electron, 2 has 2, 3 has 3, 4, the carbon family, has 4. Group 5, the nitrogen family, has 5. Oxygen has 6. Fluorine, or the halogens, have 7. And the noble gases have a full octet, which means 8 valence electrons except for helium. Valence electrons are the outside electrons. They're also our bonding electrons. They're going to determine how reactive substances are, if they will react with other things or not. Here are some examples of Lewis dot structures. I simply put the element symbol down and then I draw dots. Beryllium, magnesium, calcium, and strontium are all in group 2. Remember, you do not capitalize the second letter on the periodic table. When it comes to dotting, the reason that I have them as far apart from one another is based on the laws of electricity. Like charges repel, and so I have to keep my electrons as far apart from one as possible. It doesn't matter if I draw my dots this way or starting off this way. Now, what about if I have an element, let's say past carbon, that has more than 4? Let's go look at one. What if we do fluorine? Fluorine is in group 7. It has 7 valence electrons in the outside shell. So I'm going to call and use a cross method. 1, 2, 3, 4, 5, 6, 7. I have 7. Let's go look at, here's fluorine. Let's go look at neon, because neon's its neighbor. Let's find out why they're called noble gases. So here's neon. It has 8 in the outside shell. So I'm going to dot it up with 8. 1, 2, 3, 4, 5, 6, 7, and 8. The difference between fluorine and neon is simply the space. And because of that space, fluorine is more reactive than neon. Neon doesn't want to react. It has a full octet, just like everybody else in its group. So it doesn't want to react, and it doesn't. Fluorine, on the other hand, is highly reactive. It has a spot. It needs somebody. And so it's going to go steal one from somebody else who's around them. Group 7 is known as halogens. And they're called that because of their reactivity. When they get near something, let's say group 1, the alkali metals, they're going to steal its electron and form a salt. That's why we have so many salts we know of, like sodium chloride, sodium and chlorine together, because chlorine was unhappy with its one spot left open. So that concludes Lewis dot structure. Now it's time for you to practice.